my name is Alexander Newton with Martin County Fire Rescue's Training Bureau. Today we're going to be discussing the Akron 3000. We're going to go over the equipment itself, setting it up, troubleshooting, and then breaking it down. Alright, so now what we're going to do is we're going to discuss a couple of things real quick before we go through the setup. We are going to go through what's called the golden rules. The first thing we're going to talk about is the inlet pressure itself. Inlet pressure has to be at 200 psi at the eductor itself. If it's anywhere past over 100 feet, 200 feet, whatever it may be, you have to make sure that you calculate for the friction loss itself for it to be 200 psi at the eductor. So next what we have to discuss is that matching the GPM to the eductor. So on our eductor, you'll notice that it is supposed to be 95 GPM. If you have the chief nozzle, chief XD nozzle, that's gonna be 175. So you have to make sure you go back to our old combination nozzle and bring it down from either 1/5 or whatever it is, down to 95 before foam operations begin. All right, so now what we're gonna discuss is minimizing the back pressure from the eductor. So what this means for the Akron 3000 is that doesn't matter how far out you go, as long as you hit the 200 psi at the eductor, but then after that is when you wanna make sure the back pressure is limited. So for our Akron, or for our nozzles itself, so a 75 psi nozzle for a Class A foam can actually go up to 500 feet for 10 feet of elevation. Our Class B foam can actually go up to 400 feet after the eductor at 10 feet elevation for the 75 psi nozzle. What you want to do is for your truck specifically and whatever hose light you're going to be using, you want to check what nozzle you're using and what length of the hose you're going to be using, as well as the foam concentration. So with this, you want to make sure you go back to Akron 3000's reference guide, and that will tell you specifics. For minimizing back pressure, what you're going to make sure is that you don't want any type of kinks to the eductor and any kinks after the eductor. So if you have anything before that, you're going to limit your pressure to the eductor itself. As I said before, it has to be 200 psi. If then you have kinks in afterwards, that means that your psi at the nozzle will be limited, and then your GPM will drop as well. What we're going to do is, before connecting this, you want to make sure that there is a gasket. The importance of that is that if it is not sealed properly, you're actually going to get an air leak that can actually cause an issue with your pressure and an issue with the Venturi effect. Once you're here, when you make sure that you're connected and everything is tight, you're going to come in and connect your line. You want this to be free of any type of kinks or anything that's going to limit that pressure. So once you tighten everything up, you know how you have a good seal. At this point, you can actually go ahead and start charging down the line so they can start their firefight. You do not want to try to make sure that this bucket is on the ground. Although it can reach almost all the way down, if there's any movement, you might miss just those couple inches within the foam bucket. As we showed you before, we put the pressure gauge right here at the pump discharge, and we got to see the actual pump discharge pressure compared to right before the eductor. So what we're going to show you now is that we're going to show you the eductor 100 feet away from the pump, and we're going to see the actual friction loss, because remember, be mindful that wherever that eductor is, it could be 400 feet away, but at the eductor it has to be 200 psi. So as you saw, we pumped it at 200 for the pump discharge pressure. The friction loss is approximately 10 psi to the eductor itself. So what we did, as you can see here, it's just under, which is fine, but 100 feet, we want to make sure it's 200 psi. Although it's only 10 psi difference, again, we want to make sure this is 200 psi. So we bumped it up 10 psi, and now we're actually at 200 psi, where you can actually hear the sucking itself from this to where the jug will be. I'm having good suction now, where I know that this is going to work for whatever foam I'm using. Alright, so now what we're going to do is we're going to show you the actual application of flowing this line, and we're going to even include 400 feet, like we discussed earlier, to the nozzle, just like one of our new hose lays in the back. So I have it at half percentage right now for a structure fire. We're going to have this as Class A. If it was Class B, 400 would still work the same. So for training purpose only, We do have truck soap in here, which is what you guys are going to be using out on the street for trying this out. All right, so what we're going to show you now is that we're going to bump this up to 200 psi at the Eductor. And even though we're at 200 psi, you're going to realize there's no suction coming from this. So it's not going to work until someone downrange is actually flowing. All right, my PDP is 200. My discharge is 200. I'm still not getting any type of suction. So now I'm going to have them flow. You're going to notice you're going to start having suction with this, because he is flowing. So if they're not flowing downrange, then you're not going to get any type of suction. I know I have suction. I can go ahead where my bucket is, and I can notice there's foam coming up and out of the actual hose itself. So because we don't have air aspirating nozzles, the most important thing to do is to open up to a slight fog. And what that's going to do is it's going to create a little bit of air movement at the nozzle itself. And here what you're doing is, you can see as he's hitting it, a foam blanket should start banking down, especially Class B. It'll be a lot thicker of a concentration, and it'll slowly go down the actual tank. It has it at a downward deflection and a slight fog pattern. And what that does is it's going to actually cause a little bit of air disturbance, and then the hard compact surface will then start breaking up that foam and start creating those more bubbles. And what you're going to do is, this is called a roll-on method. You're going to create that foam blanket behind the actual air origin of fire, and then you're going to create that, once that blanket's formed, you're going to slowly push that blanket on top of the seat of the fire. At that point, you want to make sure you do not want to disturb any portion of the fire itself, especially for a Class B liquid fire. So this right here is called a rain down method. As you can see, is as it's going up in the air, it's going to break up into little particles and actually start raining down on the fuel itself, or your objective is for the firefight. All right, so now that we've went over the actual operations, how to set it up, the application of it, what we're going to discuss real quick is the troubleshooting. This is the most important part, is that, you know, if you're during a firefight, you're actually not able to get any type of foam, you kind of just do go through that golden rule again. So the first thing you want to do is you want to make sure is the suction. So as I showed you before, if they are flowing, you're going to test it, and you should be able to suck to the actual palm of your hand, and then you know you're getting good suction. If you're not, what you can do is check up here. This actually unscrews, and there could be a small or a slight air leak right here. So what you can do is just try to tighten it. If it's still not working, where you're not getting any type of suction, and this is tight, you're going to actually come and take this off. So when you take this off, you should be able to feel that there is a suction right here. Now you're going to put your hand over it. If you feel a suction and you weren't able to get a suction here, most likely there is some type of clog within this hose line and the pickup tube. So the only way to do that is try to get whatever's clogged out of it by either putting in a bucket of water, whatever it may be. Just try to get this unclogged. You're feeling a good suction on the pickup tube. This was tight. You did feel suction coming out of this. Then the next thing it's going to be is your pressure. So with the pressure, you're going to go ahead and you're going to check that your PDP, or your pump discharge pressure, and your side discharge is actually matching from your gauge to the pump discharge. Also, if you're getting good flow downrange, they need to let you know if they're getting good nozzle reaction, and then you know that your pressure is good enough at the Eductor itself. The next thing is to make sure that all your line does not have any type of kinks. The couplings are all tight, and the nozzle is the correct nozzle. Again, if you're using this 50 psi nozzle at 175 GPM, you're possibly not going to be getting any good foam blanket out of this. So you want to make sure you use the combination nozzle where you can switch to the 95 GPM for the Akron 3000. Other than that, sometimes the consistency can be a little bit different for this. So with the Class A and Class B, you want to make sure that your foam isn't gelled up so much that you're not going to be able to get any type of suction. Again, the best way to do it, know that you're having suction here, and then you're going to once you get in pressure and they're flowing, then put the pickup tube down to the through the bucket all the way to the bottom. So as we went over, as we discussed, is that we went through this whole operation for foam. We even flowed at 400 feet, and we got really good foam on the end of it. So you're going to notice that you're going to have training at the station level to go through all of this and to be able to teach as a driver engineer or a captain, where you're going to be able to teach your crew members of how to go through this, how to set it up, troubleshoot, and then be able to flow foam on a fire scene. I want to thank you again. My name is Alexander Newton, and have a good day.